All, Vinod here from Entrance Engineering Academy. Before going into the video, I just want to say a few things about Entrance Engineering Academy. So, EEA is an online gate preparation portal, and we offer full course for GATE ME and XE. In addition to that, subject courses are also available for ME, XE, CE, and PI. Engineering mathematics course is available for all stream, and in addition to that, we offer online test series for GATE ME and XE also. So this is our website. You can just check out so that you will get to know more about us. And in addition, we have our own Android app and also iOS app, and you can just go through that also to know more about our courses. Okay. And this is our last year, that is GATE 2021 result from XE. And now let us proceed to the video. And this video is taken from online video course of Endurance Engineering Academy. So let us proceed to two-dimensional motion. So listen carefully. Let us consider one example. Okay. So there is a car. Okay. Let us consider there is a car. The car is going to move in this path. Okay. You are seeing a top view of the car. Okay. You are seeing the top view of the car, and if car moves in this path, okay, then what about the acceleration, displacement, and velocity? How you are going to find out? Because here the car is not moving in straight line. Okay, it is moving in some random motion, right? Like you could see, it's moving in this direction. Okay, that is, it is not one dimensional. It is in fact two dimensional. Okay, see, since it is two dimensional, we won't consider the third dimension. Okay, that is perpendicular to the board. Those dimension we won't consider. We will consider only the plane. Okay, because it's a planar motion. Now, how to do this? See, there are generally two methods. One is Newton's approach, and another one is Euler's approach. So first we will talk about Newton's approach, and once we enter into circular motion and rotational mechanics, we will talk about Euler's approach. Right, so what is this Newton's approach and what actually he did? Newton's approach is based on a principle called as, or based on some what I could say, some reference plane or reference coordinates called as Cartesian coordinate system, okay, which is developed by Euclid. Okay, so Euclid is the name of the scientist, and he developed this Cartesian coordinate system, and Newton's borrowed this system. Okay, by borrowing this system, he implemented here, and then he given some beautiful conclusions. We will see all those things. First, we will understand Cartesian coordinate system, what actually it is saying. Simple. If there is some particle or if there is some body, for example, in this case, car, right? So, if there is a particle or if there is some object, okay. So, how to find out the position of this particular object? How can I determine the position of this particular object? See, suppose you imagine that this is a square room. Okay, so there is cubicle room. I'm placing a pen here. Okay, so you can consider there is a table. I'm placing a pen here. So how to find out the position of the pen? I cannot say that the pen was placed above the table. The pen is presented near near the door, or it is presented near the camera, or something like that. I cannot say, because mathematically I cannot define the position, right? So that for finding out the mathematical position of this particular pen or whatever the object, Newton used Cartesian coordinate system or Euclid Cartesian coordinate system, which is developed by Euclid. Okay, so what he is saying, if you want to find out position of this particular pen, okay, whatever particular object, first you choose one reference point. Okay, you choose one reference point, and that reference point, name it as origin. Okay, or just simply it is a reference point. Okay, so that is our reference point, or that is the origin. Okay, and this origin represent the initial starting stage. Okay, 0, 0, that is the starting point. Now, wherever this object is there, for example, let us consider, I am taking the marker as my example, right? Let me consider marker, I am representing it with P. Okay, so take that particular particle as one of the corner of the cuboid. For example, you consider this point as origin. Okay, this point as origin. You treat any one of the corner point in this particular cuboid to be the point P. So what does it mean? Simple. First let me draw the, what is that, cuboid. So this is our origin, whatever you want to consider, either you consider this as origin or this as origin, okay, up to you. And I'm going to treat, let me take this as my origin, okay, let me take this as my origin, and any one of the corner, okay, any one of the corner should be taken as, any one of the corner should be taken as the particle, okay. So this is my corner, I'm going to take this as the particle P, okay. So I hope it is clear. You fix the reference, reference is not going to vary, but your particle will vary, right, it can move somewhere, okay. So that particle should be taken as any one of the corner in the cuboid which you are going to form, okay. So take the particle, form the cuboid such that the cuboid should pass through this origin also. Now the three edges of the cuboid, okay, three edges of the cuboid which passes through the origin. What are the three edges? Three mutually perpendicular edges, that is 90-degree angle. Three edges are there, you could see here. This is one edge, and this is, I'm sorry, this is another one, another edge, okay, and this is another edge. So three edges which is passing through the origin, okay, three edges which is passing through the origin, those three edges are your reference axis, okay. So those are x-axis, y-axis and z-axis. Follow right and thumb rule to fix the axis. We already know forefinger, if the forefinger is representing x-axis, okay, the forefinger represent x-axis, twist it, this is going to be y, okay, and this thumb, okay, is going to be z, okay, x-axis, y-axis, thumb is going to be z, okay, follow right and thumb rule. So three edges of the cuboid which is passing through the origin will be taken as three mutually perpendicular axes, and those three mutually perpendicular axes are our reference axis x, y, z, okay. So point P, that is the particle, the position of the particle will be taken as any one of the corner of the cuboid, and three edges which is passing through the origin should be taken as our reference axis, okay. Now how to represent this point P? Simple. If it is a cuboid, then the cuboid should have some length, some breadth and some height, right? So let me take length of the cuboid to be L, and breadth of the cuboid to be B, and height of the cuboid to be H, okay. So length is L, breadth is B, height is H, okay. Now what about the position of P then? Very simple, position P will be L, B, H, okay. So length L in X direction, B, I'm sorry, I will take it as B here, okay, height as B, and this is H, okay, right. So L, B, H, so L, B, Y direction, H is the direction, so L, B, H, okay. So that point, that coordinate or point is L, B, H. So now we can clearly say, right, suppose if I spotted my reference, you imagine that this is a room, okay, in which one of the corner of the room as your origin, okay. So from that origin you can easily give the mathematical position of any particle. If I am keeping my marker in the table, I can clearly define what is the mathematical position of this marker with respect to that origin which I am taken. The origin which I am going to take here was one of the corner of the room, okay. And what actually it is indicating? Simple, this point P is present at a distance L in X direction, B in Y direction, H in Z direction, that is what L, B, H, okay. I hope it is clear, right, okay. So there it was 3-dimensional, right, so we had X, Y, Z, but here we are dealing with only 2-dimensional motion, so there will be only there will be only two directions, okay. So we will take two axes, two reference axes, one is Y and another one is X. So let us consider car is here and car started to move, and it reached this position. So this is the new position of the car, and let me mark it as P, okay. Now again as usual, by using Cartesian coordinate system, what will be my position of P? How to represent that? Simple, P is present, let us consider what I need to do. I need to form a cuboid in that case. Since it is 2-dimension, you can form a rectangle, okay. So you can form a rectangle. You can simply form a rectangle in which one of the corner of the rectangle should be that particle or should be the body for which I need to find out the position. So this corner is my body or is my particle, and these are my rectangle, okay. So now this point P is present at some distance in x-axis, let me take x, and this point P is present at some distance in y-axis, let me take y, okay. And this line which is going to connect, it is OP, and what is the significance of OP we will see. We already know that in fact, okay. Now this is what Euclid said from Cartesian coordinate system, and what Newton did was he just modified something. The modification is something like Newton taken unit vector along x-axis as I dot, that is I cap, and unit vector along y-axis as j cap. Okay, so this I cap and y cap, or I cap and j cap are simply unit vectors along x and y axis, and their magnitude is obviously going to be 1, and they are just representing the direction. So what is this I and j representing? Simply it is representing I representing the direction of x axis, j representing the direction of y axis, nothing else. Now simply if you want to find out position of this vector p, we already discussed this in fact. So position of this vector p is represented by what? OP vector, right? So position of p with respect to O. So what is this OP vector indicating? Position of P, okay, with respect to O. This P is the body or the object for which I need to find out the position. O is the reference, okay. So always if it is OP vector, it is position of P with respect to O, okay. Suppose if it is AB vector, what it is indicating? Position of B with respect to A. If it is BA vector, position of A with respect to B, which means A will be the object where I need to find out the position, B will be the reference point, okay. In this case, this is our reference point, and this is going to be our object for which I need to find out the position, okay. So Newton did this, he invented vector calculus, and he found out that position of any particle can be determined by using position vector, in this case OP vector, which is nothing but position of P with respect to O, that will be given as x I cap plus y j cap. So what it is indicating, let me explain. So with respect to reference, okay, from the reference point, that is from origin, if you travel x direction in x-axis, okay, this is representing magnitude, how much magnitude you need to travel in x-axis, this represent the direction. So I represent x direction, so in x direction you travel x distance, and in y direction, that is j cap represent y direction, you travel y distance, you will end up reaching P, okay. So x direction you travel what is that, x distance you travel in x direction, y distance you travel in y direction, you will reach the position, okay. So that is what Newton said. Similarly we can see for 3 dimension also, you could very clearly, and one more thing is there is no necessary that you need to travel in x and y, okay, you can travel in y and j also. For example, I travel y direction in, you could see clearly, I'm traveling y direction in y axis from the origin, then x direction in x axis, then I will be reaching the point, whichever the desired point. Now coming there, point P is there, right? So what about the case LBH, which means I need to travel L direction in x axis, B direction in y axis, and H direction in z axis. If I do that, I will end up in the point P, okay. So from origin again, so from origin, let me consider I'm traveling, I will use another color, okay. So I'm traveling L direction, okay, in x axis, and B direction, okay. So I reached here, so from here B direction in y axis, now I reached here, okay, which means this point, okay. Now from there H direction in z axis means perpendicular to the border, right? So I'm traveling H direction to reach the point P. So L direction, that is L amount in x direction, B amount in y direction, H amount in z direction. You can vary it also. For example, you can travel, first you can start with B. For example, I am here, I am traveling B amount in y direction, okay, I am traveling B amount in y direction, then I am traveling x amount, okay, in x direction. So x amount means it is going to be this, right, x amount in L amount in x direction, then I am going to travel H amount in z direction, I will end up in the point P, okay. So very simple concept. The fact here is this I vector there, if it is that case, it's going to be I, j, k. I forgot to say that. So I vector, j vector, k, I cap, j cap, k cap, where those are the unit vectors along x axis, y axis and z axis. Okay. Now, so we got this right. So this is something which has been said by Newton. So we identified it. So from this we can easily find out the position of this particular point P. Now let us consider a car is moving from P, okay, to some other point Q. Okay, now how to find out the displacement? We already know that. Okay, we already know that. How to find out the displacement? Displacement is nothing but, I will use another color, I'm sorry. Displacement is nothing but simply PQ vector. Am I right? PQ vector. So how to find out this PQ vector? Okay, or in other sense, PQ vector is nothing but S vector, which is displacement. We already discussed when I was starting the displacement first. So simply position vector of Q vector minus position vector of P vector. So position vector of Q, that can be given by connecting this to, okay, so this will be OQ vector is position vector of Q, OP vector is position vector of P, and if I subtract those two, I will get the displacement, which is PQ vector. So OQ vector minus OP vector will give me position vector. So we understood the basic idea about Cartesian coordinate and how we are representing any point, okay, the position of any particular particle or position of any particular body in Cartesian coordinate. So we will be using technique of vector calculus, that is I vector, j vector, k vector. By using I, j, k, I will be specifying the direction, and xi, okay, that x represent the magnitude, similarly y represent the magnitude, z represent the magnitude in that particular direction. Okay, so all these things we discussed, and from origin we need to travel in x direction and y direction and z direction to reach that particular point. Okay, these are the basic ideas which we discussed. And for finding out position vector, for example, we are going to deal only with 2 dimension, as we already know that. If suppose this is the particle which is moving in this path, okay, if I want to find out position vector of this particular particle, that is its displacement from origin, okay, from origin, then it's simply going to be xi vector plus yj vector, okay. So OP vector, that is this vector, is going to be S vector, which is equal to xi vector plus yj vector, which is position vector. Now, the next thing is what I need to find out, and similarly we seen that if this particle travel from this point to this point, how to find out the displacement between those 2 points, that also we seen, right? That is, if it travels from P to Q, then PQ vector will be equal to OQ vector minus OP vector, okay, so which we already seen that in the last video. Now what we are going to do, we are going to extend our case to velocity and acceleration. So how to find out velocity and acceleration in 2 dimensions by using Cartesian coordinate? Simple, straightforward only. We already know that this equation, okay, this equation can be applied for anything without any, there is no assumption which is involved there. From the basic definition of velocity, actually, velocity is nothing but rate of change of displacement. So just I need to differentiate the displacement with respect to time for getting velocity, okay. So here the position vector, okay, the displacement is xi vector plus xi cap plus yj cap. So d by dt of xi cap plus yj cap. Now I'm splitting it, okay, I'm bringing this integration inside. So by d by dt of xi vector plus d by dt of yj vector. Now again, this is u, this is v, this is u, this is v, uv method, okay. So d by dt, we know that differentiation of uv is nothing but u dv plus v du, right? So I will take this as u, okay. So I vector d by dt of x vector, okay. So I need to keep one as constant, I need to differentiate another. So I d by dt of x plus x di by dt, okay. And similarly here also j dy by dt, okay, plus y dj by dt. Now there is one important conclusion which we need to understand. Basic conclusion only, very easy. If you observe this particular thing, okay, let us assume that this is the particle, okay, this is the particle which is going to travel in this path. Okay, you can imagine a vehicle or car or something like that. So some car is traveling from this point and it is traveling in this path, okay. It's keep on moving and it's keep on continuing its path. If the car travels in this path, was there any change in x and y? Of course xy changes. If car is present here, then there will be different x value. If a car is present here, then x value, y value will be 0, 0. If it is present here, x value, y value will vary. Here it will vary, here it will vary, here it will vary, here it will vary. So if car keeps on moving with respect to time, x value and y value will change. Obviously the position will change, so x value, y value will change. But what about I vector and j vector? I vector is the unit vector along x-axis. J vector is the unit vector along y-axis. Was there any change when car moves or when the particle moves? There is no change. Obviously there is no change. This I vector will be always I vector. It will be always oriented towards x-axis. This j vector is always j vector, and it will be oriented towards y-axis. And that is what it is. Fixed vectors. Okay, they are fixed vectors, which means they won't vary even though if time varies, even though the position of the particle varies. I vector and j vector, they won't vary. Okay, so that is something which you need to note, and hence this Cartesian coordinate system is also called as space fixed coordinate system. Since the I and j is not varying, right, they will be always constant only whatever happens. Whatever may be the displacement, whatever may be the velocity, whatever may be the acceleration, I and j will be always constant, no change in that. Okay. Now what I need to do was simple. Since they are fixed vectors, di by dt, that is differentiation of I with respect to time, that obviously will become 0. And dj by dt, that will also obviously become 0. Okay. So remaining this term is there, and I am writing that there. Okay. So dx by dt I cap plus dy by dt j cap. See, dx by dt into unit vector. This vector is representing x direction. Okay. dy by dt into j vector, that is unit vector, and that vector representing y direction. Velocity vector is equal to this. Okay. So obviously this term dx by dt and similarly this term dy by dt should be a velocity only, right? Obviously it cannot be acceleration, it cannot be displacement, it cannot be anything else. So this dx by dt has to be velocity only, and velocity in what? Velocity in x direction, y, because I am multiplying it with I vector. And this is velocity in y direction, y, because I am multiplying it with j vector, because I and j represent the directions. Okay, so I am going to represent this dx by dt as vx and similarly dy by dt as vy. So this is our velocities. Okay, so let us see acceleration also. So now we will find out acceleration vector. Okay, so very simple. Again, we know the basic formula. Acceleration is nothing but rate of change of velocity, and velocity v vector just now we seen, we can write it as vx I vector, vx I cap plus vy j cap. And again this is going to be what I could say, this first I need to differentiate this. If I try to differentiate this, I need to keep one constant and I need to differentiate other. So first I am keeping I constant and I am differentiating vx, and next I am keeping vx constant and I am differentiating I. Okay, and when I enters here, I'm differentiating vy first and then I'm differentiating j constant. Here I'm differentiating j first and I'm keeping vy constant. Again, as we already know that I cap and j cap are fixed vectors, their differentiation will be 0. Okay, so they won't change with respect to time. So dv by dx, dvx by dt I vector plus dvy by dt j vector, this will be my acceleration formula. We also know that vx is nothing but dx by dt. So if I substitute in place of vx dx by dt, I will get d square x by dt square. And similarly in place of vy, if I substitute dy by dt, I will get d square y by dt square. So this also the same thing only. And again, as usual, what we did in the last case, this is some quantity multiplied by I cap, this is some quantity multiplied by j cap. We know very clearly these are something which is representing a vector, right? So it is representing acceleration. So this is going to be acceleration in x direction, this is going to be acceleration in y direction. Similarly, this is acceleration in x direction, acceleration in y direction. So instead of these two, I can write it as ax, and similarly here I can write it as ay. This is also a general form. Okay. There is one very important conclusion from this particular topic which we are discussing, two-dimensional motion. We got an equation for velocity vector, acceleration vector and even position vector. But when we are applying in problems, there is one very important conclusion, or there is one very important thing to note here. Okay, listen carefully. I will say one story. Okay, it's not a story, the thing which has actually happened. Okay, so during the English period, that is during the British period, when British was ruling India, they had one issue. Okay, they had one issue in the state Bengal. The Bengal state is nothing but, in present it is Bangladesh and West Bengal. Okay, so earlier it used to be single state, which is Bengal. Okay, and the issue which they faced is, obviously the major reason why the British was ruling India is for collecting taxes and then taking back to London. Okay, so they felt very difficult to collect taxes from a single state of Bengal. So now they implemented one a very good technique, so that their work will be splitted up and their work will become very easy for them. The technique is divide and rule. Okay, divide and rule. Simply they divided Bengal into two. Okay, one is West Bengal and another one is Bangladesh. Okay, and they started collecting taxes separately, and after that they brought it back to London and they mixed it. Okay, simply the aim of British is to collect taxes to earn money. Okay, it is not for developing the state, or it's not for developing the country. Just they want to collect taxes. So they felt very difficult for collecting taxes as a single state. So they splitted, they partitioned it, and they collected taxes separately. Okay, dividing and ruling. So they just divided it, and they collected taxes from Bangladesh separately. They collected taxes from West Bengal separately, and later they mixed it in London. Okay, right. That's fine. Right, now why I said this story here, very simple concept. Here displacement vector, or velocity vector, or acceleration vector, or whatever it is, what Newton did was, which is similar to that of this divide and rule policy. What Newton said, simple, the component of velocity, or component of acceleration, or component of displacement in x direction is unaffected by component of velocity, or component of acceleration, or component of displacement in y direction. So if there was any two mutually perpendicular direction, not necessarily x and y, okay, if there is two mutually perpendicular axes, the component of velocity, acceleration, or displacement in this direction will be unaffected. Let me take it as 1, 1, 1 will be unaffected by V2, A2 and S2. So the components are unaffected with respect to their perpendicular direction. What does it mean? The components in x direction, I'm just giving you x and y axis, but in general it is two perpendicular direction. Okay, so components in x direction will not get affected if there was any change in components in y, and components of y will not get affected if there was any change in x. So very straightforward thing. So because of this, what we got? Simple. We can find out velocity, acceleration, displacement in one direction separately, and we can find out velocity, acceleration, displacement in another direction separately. That is, we can find out x component value separately and y components value separately, and finally I can mix to get the resultant. This is something which Newton said, and which is very important conclusion. Once we start moving forward also, it will be useful. It's not only applicable for velocity, acceleration, it's applicable for forces also. Okay, so just simply you find out components in x separately, find out components in y separately, then mix it, so that you will get the resultant, which is similar to the division of Bengal into West Bengal and Bangladesh. We will collect taxes from West Bengal separately, collect taxes from Bangladesh separately, finally you mix it. Similarly, you calculate, you do the problem separately for x direction, you do the problem separately for y direction, then finally mix it to get the resultant. That's it. Very important conclusion, note it down properly. Okay, so separately do the problem for x axis, separately do the problem for y axis, finally you mix it, you will get the resultant. And let us give some conclusions related to that. We already know that S vector, okay, which is going to be what? S vector will be xi cap plus yj cap, and if I want to find out magnitude of this S vector, it's going to be root of x square plus y square. If I want to find out this angle, the direction, then tan theta will be equal to what? Tan theta is opposite by adjacent, right? Opposite is y, adjacent by x, so adjacent is x, so y by x, which implies theta is equal to tan inverse of y by x. Okay, now coming to that point, here we will take velocity is oriented at an angle alpha with respect to horizontal axis. Okay, here horizontal axis again x only. So I am going to represent different angles. Okay, for a displacement vector I am taking theta with respect to x axis, and again this is displacement with respect to x, it is theta. Velocity, it is alpha with respect to horizontal axis, and similarly for acceleration I am taking beta with respect to horizontal. Okay, this is an horizontal axis. The dotted line which I drawn is a horizontal axis. So with respect to horizontal axis, angle will be alpha for velocity. So in general, what is going to be my velocity v vector? It's going to be vx I cap plus vy j cap. So you can find out vx separately, vy separately. We already know the formula dx by dt, dy by dt. Then I can compare it. Then I can combine it to get the total magnitude of the velocity. And if I want to find out tan alpha, okay, what's going to be tan alpha? Simple, let me show you. Yeah, this is v vector, right? So horizontal component and vertical component, this is alpha, right? So horizontal component is going to be vx and vertical component is going to be vy. Okay, vx is nothing but v cos alpha, vy is nothing but v sin alpha. So simply tan alpha will be nothing but what? Opposite by adjacent. So opposite is vy and adjacent is vx, so which implies alpha is equal to tan inverse of vy by vx. Okay, now coming to that point, similarly acceleration, okay, this is beta, angle with respect to horizontal. So horizontal component of acceleration is ax and vertical component is going to be ay. So first let me write a vector, which is ax I cap plus ay j cap. Okay, and the magnitude value is going to be root of ax square plus ay square, and tan, what is the value? Tan beta, right? Opposite by adjacent. So tan beta is going to be ay by ax. So beta is tan inverse of ay by ax. Okay, so these are very easy things only. The fact here you need to notice, find out x direction separately, y direction separately, and then combine it to get the final result. And again, velocity and these things, displacement, we have another formula also, which is something we will be applying one condition. What is that condition? I will say, just wait for a moment. So we will discuss that formula now. So in the last video, we given a conclusion that you need to solve x direction separately, y direction separately. You need to find out vx, ax, and the displacement in x direction separately, and then you find out uv and like what else, velocity, acceleration, everything in y direction separately. Then finally you can combine it to get the resultant, right? Now there is one more formula to add that. Okay, so how you will be doing it? Listen, in x direction we know velocity is equal to dx by dt, acceleration is equal to dvx by dt. And the important point is, for these two, using these two, there is no assumptions. We can use it anywhere. Just it has to be two dimension in which x direction component can be determined by using this two. And if acceleration is constant along x direction, this is very important. Very important. You just worry only about x direction, because I am concentrating only on x direction, right? Don't worry about y direction. So if acceleration is constant along x direction, then I can use the three equations which we got for acceleration constant condition. Don't worry about y direction acceleration. Even though if y direction acceleration varies also, okay, even though if it is varies also, if x direction acceleration is constant, then we can use these three formulas. What actually I did, this is final velocity in x direction, initial velocity in x direction, plus acceleration in x direction, which is constant, into time taken. Okay, this is displacement in x direction, velocity in what is that, x direction, initial velocity in x direction t, plus 1 by 2 into ax t square, and this is final velocity x direction, initial velocity x direction square, again 2ax into x. So the three equations which we already got, v is equal to u plus at, s is equal to ut plus 1 by 2 at square, v is equal to u square plus 2as. The same equation only here I am completely applying for x direction. When I can do, if x direction velocity is constant, don't worry about y direction velocity, y direction acceleration. If x direction acceleration is constant, don't worry about y direction acceleration. Now coming to this, same logic only. These two formulas I can apply everywhere. Okay, if a direction acceleration, okay, if a direction acceleration is constant, then I can use these three formulas. Okay, this is nothing but the three formulas which we already discussed, and here everything should be y component. That's it. Okay.